Hi everyone, I'm going to go over assignment 3 very briefly because it's essentially the same as assignment 1. So the big takeaways from this, almost all the things we were doing for assignment 1, we'll do again for assignment 3. The difference is we'll be using classes instead of structs. So instead of the tree 2400 struct, we now have a tree 2400 class here and here. .h files and .cpp files, 2 files for one class. So one of them says this is the blueprint for this thing, or just the outline, if you will, and then the other, the CPP file, defines all our functions. We'll have a tree node class, so tree node.cpp, tree node.h. And we will also be doing things like, we won't be necessarily reading in from a file, although it's an optional bonus question. I did it. I can actually run the code here right now for you. We have finding or doing a search with the, no, that's the media file. That's for next assignment. I'm getting ahead of myself. We're doing things like, let me have a look. So here is my tree node. I have a constructor right here. I have a destructor, the thing with the tilde in front of it. That's a destructor. As in, whenever I destroy one of these things, when I remove it, I will do this. I have a function called getID. It will find the ID or return the ID for the particular tree node that I'm in. I can get the child of my tree node, or I can get the other child of my tree node. I can set those children. These are my setter and getter methods. I will have getting the text information from this thing. So it allows me to output information about the tree node. So if I want to say it's ID 1 and it has child nodes 3 and 4, that's what it says. And maybe it says it in text. I'll show you an example of it in a second. This is for our optional section. If I wanted to print off everything, print off the entire tree node, I could have something like print tree node n below, as in all n elements below, the tree node and below, n below. It prints off all the elements from that node and all the children and all the grandchildren, great grandchildren, all the nodes in the tree. So I go to the root of my tree, call that function, everything gets printed off. And we have a fancier version of it, which is printing off a more advanced version of print tree node n below. We can find out the number of ancestors. We can get whether two nodes are connected. You'll also be doing is find a node, and so we can look for a particular ID, see if it's in there in the tree, and we have is something a child. So let's have a look, or is something a leaf, right? These are the functions I'm going to be implementing. They're like the sub-functions we did last time. The difference is from the perspective of the object that I'm looking at. So I say, hey, you tree node, are you connected to this other node? And it says, yes, I am, or no, I'm not. Rather than pass two tree nodes in and say, hey, are you these two things connected? You're asking one of the tree nodes, hey, is this your child? And it responds. It's from the perspective of the data. The data knows how to deal with itself. So let's run this thing. So I have, let's see here, this many classes. I'm reading in this particular tree node formatted text file like last time. Here is my actual code, my main method. So if I'm reading in a file, I'm allowed to use couts, by the way. I make a tree 2400 object with this particular text file being read in. I say, hello world, there are this many nodes read in, great. And then I print off my tree. And when I'm done, I'm going to, when all this is done, when my tree gets deleted, I'll point out this, when my tree gets deleted, it's my numeric array. Here we go. When it gets deleted, I have an output statement saying, I'm deleting the tree node at the start, I'm deleting it at the end. Let's have a look at this in action. Okay. Oh, I gotta move this over. So let's have a look. Hello world, there are 13 nodes read in. So I've read in the file. I print off my tree. Notice 1 is connected to 2 and 3. Node 2 is connected to 4 and 5. Node 4 is connected to 8 and 9. That's a nice way of, or one of the ways you could display what the nodes are and what they're connected to. This node with this number 4 is connected to nodes 8 and nodes 9. Node 8 is connected to nothing. Node 9 is connected to node 13 and nothing. Node 13 is connected to nothing. Node 5 is connected to 10 and nothing. And I can just read off how my tree is formed in this way. It's one way of doing it. I think it's the easier way to do it. And then at the end, I delete my tree. So deleting the tree, start. Hey, look, I delete all my nodes in my tree, and then I delete tree end at the end. What I want is that when I call delete on one node, it deletes the child nodes, and then it deletes, and then removes itself, essentially. I want to think about the data from the perspective of the objects that I'm creating. I make an object, a node, and it knows what to do with itself. How to be created at first, how to give and get data, how to set data for itself, and how to delete itself at the end. And that's what we're practicing this week. It's the exact same thing as last time with our tree. The difference is that we are making objects now. And those objects, it's a more intuitive way of thinking about your things. So instead of having to pass in like an array list of things, all I do is I pass in a tree and I say, hey, print yourself. And then it goes to the first node and says, hey, print yourself and all your children. And that thing that prints itself and then calls the print on each of the children. And it can just, functions can call functions, which can call functions. And that's actually how I get this particular behavior up here. Okay, I'm hoping that makes sense. Start early just to get a feel for making an object. Don't memorize it. You have to sort of get used to making objects, because we're about to hit inheritance, and that's when things get really, really weird. So when we make our objects, most of the time our member variables are private, and we make functions to give us access to those private member variables. That's the thing to look for. So you can, if you go into my tree node.h, here's my public variables, and here are my private variables: the ID, the child1, and child2. You can't directly access my children or my ID. You have to go through a method like get child1, get child2, get ID, to make sure that somebody can't just walk in and just change my data on me. It's information hiding. For all I know, there's no actual number there. Maybe it's a string. I don't know. I don't care. That's the point. The data, it gives you access, but there's an interface. There's a thing giving you access to the data, but you don't directly manipulate the data. So you can track who calls this thing and how it's getting access, rather than just stomping on data. Okay, I'm going to leave it at that. Hopefully that makes some sense. If you don't know what to do for the task, watch assignment 1's video as well. That might be useful, because it's the same thing that we're doing. All right, thanks everyone, and I'll hopefully talk to you soon. Thanks.